Hi there, in this video I'm going to go through the vector product, or it's sometimes referred to as the cross product. So let's title this vector or cross product. Let me underline this as well. So if you're given two vectors A and B, then the vector product and it's denoted by A cross B. Okay, so to work out A cross B, the vector product of A and B, it's the modulus of the vector A multiplied by the modulus of the vector B multiplied by sine theta. So theta is basically the angle between the vectors A and B multiplied by a unit vector n cap or n hat. Okay, so let me explain. So let me have a diagram also. So if we have two vectors, so if this is the vector A, okay, and if this is the vector B, so A cross B, so if you calculate A cross B, the cross product of A and B, you're going to produce a vector which is perpendicular to both A and B. Okay, so here's the vector A cross B, and n cap or n hat is a unit direction vector of A cross B. So if you work out A cross B, n hat gives you the direction of A cross B. Okay, so vectors, as we know, have direction as well as magnitude. So A cross B produces a vector perpendicular to A and B in this direction. But if you work out B cross A, you're going to have a vector which is perpendicular to A and B, but in the opposite direction. So this is the vector B cross A. Okay, so you can say that A cross B is minus B cross A in vectors. Okay, so there's a quick way to work out the cross product. So let me go through the quick way. So this way over here, so this result over here enables you, in order to work out the angle theta. So theta is the angle between your two vectors A and B. So you can use this formula to work out the angle between the two vectors A and B. But let me give you another way to work out the cross product straight away. So if you have a vector V1 which is given by A1I plus B1J plus C1K, okay, and if you have another vector V2 and if that is given by A2I plus B2J plus C2K, okay, so let me show you how to work out V1 cross V2. So to work out the cross product or the vector product, another way of working this out straight away is to work out the determinant of a 3x3 matrix. Okay, so when you calculate the determinant, so when you construct the determinant, the first row is always the unit vectors I, j and k. So along the first row it's always the unit vectors I, j and k. Along the second row, these are the coefficients of I, j and k in V1. Okay, so you start with V1 and the coefficients of I, j and k in V1 are A1, B1, C1. So you write down A1, B1, C1 in that order. And in the third row, these are the coefficients of I, j and k in V2, which are A2, B2 and C2. So A2, B2, C2, and also you write down those components in that particular order, in the order I, j and k. Okay? So as you may know, when calculating the determinant of a 3 by 3, you can expand by rows or columns. I normally expand using the first row. So there are signs associated with these rows, and the sign associated with the first row of a 3 by 3 is plus, minus and plus. So I'm going to expand using the first row. So when we expand using the first row, it's plus I multiplied by the determinant of a 2 by 2 matrix. So to find the elements of that 2 by 2, all you do is cross out or forget about the row and the column associated with that element. So if you cross out the row and column, so if I take these two, okay, if I cross out the row and column associated with I, we have B1, C1, B2, C2. So those will be the elements of the first determinant, okay? Minus j, so minus j multiplied by the determinant of a 2 by 2 matrix. So remember the idea. So just cross out the row and column associated with j. So the elements of this 2 by 2 determinant are A1, C1, A2, C2, okay? And finally plus k, so plus k multiplied by, and do the same. So cross out the row and column associated with k, and the elements of that determinant are A1, B1, A2, B2. So A1, B1, A2, B2. So what we need to do now is expand further. So it's going to be I multiplied by. So as you may know, when we expand the 2 by 2 determinant, first we multiply the elements along this diagonal. So along the diagonal highlighted in red, that is what we call the leading diagonal. Then we subtract, and then we multiply the elements along the opposing diagonal, highlighted in green, that is the lateral diagonal. Okay, so let me multiply the elements along the leading diagonal, the diagonal highlighted in red, B1 times C2, B1 C2, then we subtract, then multiply the elements along the green diagonal, C1 times B2, C1, B2, okay, minus J, doing the same here, so multiply the elements along the red diagonal, then subtract, then multiply the elements along the green diagonal, so A1 times C2, A1, C2, then subtract, C1 times A2, C1, A2, plus K, open a bracket, so let me continue here. So remember, multiply the elements along the leading red diagonal, A1 times B2, A1, B2, then subtract, then multiply the elements along the green lateral diagonal, B1 times A2, B1, A2. Okay, so once you simplify this, that will give you the answer for the cross product V1 cross V2, and the answer will be a vector. Okay, so remember, in one of the videos when we worked out the scalar or dot product, the answer is a scalar, but when you work out the vector or the cross product, the answer will be a vector. Okay, so that ends this video. In the next video I'll go through some examples to show you how to apply this approach to work out the cross product of two vectors. So I hope to see you then.